didn't think about Pythagorean theorem, I don't think, when you see this. But if you look at it, I'm wondering if we can make a right triangle out of it. And you've actually got two options. You can make your right triangle up this way, or you can make your triangle this way. But if you'll take your 2 points and go horizontal with one of them and vertical with the other, you're actually making a right angle. Now, because it's distance, we're not worried about the points, per se, of the ordered pairs. So we're trying to find this one. So I'll put x because we want to know the distance, which is the hypotenuse. Your hypotenuse will always be your distance unless it's a horizontal or a vertical. And if you had a horizontal, you don't have to draw this. But if you've got 2 points like this, they're just 2 units apart. What's the distance between them? 2. If you got 2 points up and down, you know, it's 3. But if it's on a slant, you can't count across those, you know, across the grid there. So it's kind of hard. So in this case, now that -2 there is there because that's that point. I wish they didn't put that there. But do you notice that this leg, and I'm going to do an arrow, of our triangle is a 2. And this leg, I believe, is a 4, isn't it? The Pythagorean theorem says leg squared plus leg squared, it doesn't matter which one you do first because they're both legs, is equal to the hypotenuse squared. And your algebra looked very good, those of you that have done lesson 21. So I've got 4 plus 16 equals x squared. I'm going to go ahead and switch that side symmetric property and put x. I just like my x on the left. That's just me. Equals 20. Square root. Now, if you do that in your head, that's your business. But remember that 20 has a radical over it. It's a square root of 20. Now, is that simplified? 20 is not a perfect square, but it will break down. The factor tree of 20 is 2 times 2 times 5, which there's your perfect square, okay, right there. So I've got the square root of 2 squared times 5. I try not to leave a lot of things out just because I've got people, I don't like that equals. I don't like 2 equals in an equation, so I'm going to come down here and do it like that. And then we can take the square root of the 4 out, and so that comes out rational, which is 2 squared of 5. And that's the exact distance. Now, if you were punching on a calculator, if on the ACT or in science class you were doing it, it's actually, instead of typing 2 times the square root of 5, it's easier to just do square root, which is on the, let's see, it should be on the x squared key. There it is. Here's your x squared key, and it's the blue right here, so second square root of 20. Now, it's got open parentheses, and I always say, you know, in English, you never have one open without it closed. It will, if you hit equal, it'll give you the answer, but I just say it's always a good habit to close those parentheses because sometimes it'll get you. So if you were rounding that, it would be about 4.5, 4.5 units, whatever we're doing. But definitely in math, we stay with that. Now, let's do it. We'll call this problem number 1. Now, let's talk about the distance formula. Now, look what you're actually going to do. We're going to say, we know leg squared plus leg squared equals hypotenuse squared. Now, I'm going to do kind of a weird thing, but look, if I take the square root of that side, I can take the square root of that side. Well, the square root of hypotenuse squared is hypotenuse. Now, this one you might think it's the square root of leg squared, but that's not times. See, we haven't done addition inside, so just write it like this. I know it's not what you think it's going to be, but that's as far as you can actually simplify it. Now, that's what the distance formula says, and we want to talk about how we get those things. Well, we know the hypotenuse is the one we want to know, so I call that my D. Now, and then we're going to have a big square root. And we want to know how we get this leg, like this distance right here. Well, if I know this ordered pair, I know that ordered pair, which remember, it comes x and y. So that point is -1, -1. And if I know this point is -1, -3, then I can subtract -1 and -3, and remember, we only want the positive distance, and get that. So what are we actually subtracting? We're subtracting the y's, we're subtracting the x's, that's what we're doing. And so that is, and that's where it looks a little more complicated, but it's a form of the distance formula, of the Pythagorean theorem. So we're going to say x sub 2 minus x sub 1, close parentheses, squared. That's leg squared. That's actually the length of this one. That's the length of your horizontal. That's the x's. Plus, see, now we want to know the other leg. You can find this leg by subtracting the y's, and we call it y sub 2 minus y sub 1. It means that you've got 2 points on a grid. It means you've got, well, let's just do one, number 2. Let's do the point 8, 5, and let's do the point 10, 12. So you have to kind of know where those numbers come from. It's called x sub 2 and x sub 1 because that means you've got 2 sets of numbers here. So we're going to call this one x sub 1, comma, x sub 2, y sub 1. Write that above that point. We're calling this our first point, and we're going to call this one x sub 2, comma, y sub 2. And we're calling that our second point, because if you just say x, y, we don't know which one we're talking about. So if you do it by the algebra, we're going to say distance equals big square root. Now, in parentheses, we're going to subtract the x's. And I let 10 be my first one. So I'm going to say, see, I said let it be x sub 2. So we subtract the x's. So I'm going to say 10 minus 8. That gets the side. That's the 2. And we're going to square it. Leg squared. Plus, now we're going to subtract our y's. And so in this case, I started with a 12. See, that's my 2. It doesn't matter which way you subtract, but you need to go this, like if I start with a 10, I got to start with a 12. So we're going to say 12 minus 5. That is going to be that 7. That's that distance down here, and we're going to square that. Now that can be negative, but what happens when you square a negative? See, because when you square it, if we put our letters to this and we get negative numbers here, but when you square it, it becomes positive. So D equals, okay, big square root. Now I want you to put all these steps in your notes because a lot of people don't write these correctly. When we subtract these, we're going to keep them in parentheses. So we're going to put 2 squared plus 7 squared. Because a lot of people don't know when. When do I leave parentheses? If you don't know, put them all the time. We'll do one in just a second. Equals, I'm going to scoot down a little bit. Big square root, 2 squared, 4. 7 squared, 49. Now, order of operation means you do what's inside first, and we're going to say the square root of 4 plus 9, 4 plus 49, which is 53. That is our exact answer. Will it break down? Will it break down like 20 did? I think you had some in your classwork, I think in lesson 21, that didn't break down. You get some that the factor tree is just 1 times 53. It doesn't have any repeat numbers, so that's your answer. The distance is the square root of 53. It's a little bit more than 7, because 7 squared is 49, 8 squared is 64, so it probably is just a little bit more than 7 is what the distance is. You have some of these, and you have some of these. Let's do the other one, and we'll be through. Number 3, top of page 51. This is the orange one. It absolutely does not matter if you make your right triangle go in this way or if you make it this way, because the leg here is going to be the same as this leg. You're making a rectangle if you do all of it, and you know this distance is going to be the same. So let's go this way. I just kind of like to make it up and down. So our hypotenuse is our distance. You can even call that D if you want to. And notice that this is a 1. And this is a 1, 2, 3, 4, 5. Let me make sure. I think it's a 6, isn't it? 1, 2, 3, 4, 5, 6. So leg squared plus leg squared. I would encourage you to put, even though you know 1 squared is 1, go ahead and write this, especially for your notes, equals x squared. The graph paper ones are the easiest ones. 1 squared is 1. 6 squared is 36 equals x squared. I'm going to turn it around as x squared equals 37. Square root, x equals, will 37 break down? Does it? Factor tree, it's prime. 1 times 37, that's it. So x is a little more than 6 if you round it off. See, square root of 36 is 6. Square root of 37 is a little bit more. Let's do 8, -3. And let's do -7, 5. Now, here you can do it this way. You can do x, y, x, y. Now, the reason I do it that way, even though I didn't put the numbers on them, I know I'm going to have to subtract the x's and square them, and I know I'm going to have to subtract the y's and square them, and I don't label them because I'm pretty much going to ask you which one do you want to start with. So d equals, let's write the formula again. We're going to subtract our x's, x sub 2 minus x sub 1, that's the leg, and we're going to square it. We're going to subtract the y's, y sub 2 minus y sub 1, and we're going to square it. Leg squared plus leg squared equals hypotenuse squared, and we took the square root of it. That's why that's big square roots on there. Okay, Liam, which y up here do you want to start with? X, I'm sorry. Which x do you want to start with?
The -7.
Okay, so we're going to start with the -7 first, so we'll start with the 5 first. That's why I say it that way. So we're going to say, and you need to write it. Let's not shortcut. Let's put -7 minus 8 in parentheses squared, and I didn't put my big square root. Plus, people skip this step and the next one, and that's where they make careless mistakes. You got to be careful. And then if you started with a -7, let's start with a 5. 5 minus -3 squared. Leg squared plus leg squared. This is just counting the spaces between the x's. It's like what we did here and what we did here. I could almost do that one, and time-wise I would, but you can do it by the formula or you can do it by the picture. It's totally up to you. Let's see where we are. D equals big square root. Okay, -7 minus 8 is -15. If it's negative, it has to be in parentheses, so I'd say put parentheses on everything. And then what's 5 minus -3? 8 squared. And I know if you're like every student I've ever had, they want to skip steps. Just be careful, because then they get on tests and they have no clue what to be doing. -15 squared, that's why you have to put parentheses around it. Negative times negative is positive 225. If he had started with the 8, he would have said 8 minus -7. It would have been 15 squared, which would be 225. And then you would have got -8 here, so you would get the opposite. But that was also, these are always going to be positives. You square a positive, you get a positive. You square a negative, you get a positive. And then when you add those together, you get 289. Now, this is a crazy one, because people look at that and they go, that's got to be prime. It's too crazy. And if you start trying to do the factor tree, I don't think you're going to see it. And I don't know what to tell you other than you're stuck and you think, I don't know what to do with it. So you get your calculator and you simply start, in this case, with the square root of, which we said is right here, second square root. Oh, I guess I got to turn it on first, don't I? Second, am I on screen? Yeah. Square root of 289. I will close it, good habit, because in Algebra 2, there are places where you have to close a parenthesis. So I just do it even though it'll give you the answer anyway. And hit enter, and look at that. It's exactly 17. Now, that's unusual to get it. If you do the factor tree of it, I don't think, you go through them and you try 2. It won't go. It's even. 3. The trick for 3, do you remember it, is you add the digits. 2 plus 8 is 10, 19. 3 won't go into that. 4, the last 2 digits. 5, it ends in 0 or 5. 6, 2 and 3 have to go. 7, I don't remember. I don't know if there is a rule for that one. There probably is. 11, I mean, it's just one of those that your last resort is to check your calculator, and that's probably the best thing to do. That's the hardest part, is breaking these down that are a little bit weird looking, like you had in classwork.